Okay, today we are working on this assignment here, evaluating data with histograms, box and whisker plots, and dot plots using Desmos. We've done some Desmos stuff before, but I think we did something a little bit different. So what we're going to do today is we're going to get a big set of data, and be sure to watch the directions here, but basically this video is going to show you how to do, there's 3 data sets, okay? There's data set for city A, and then city B, and then city C, okay? It looks like it is a lot of questions, but the questions, you get the answers pretty quickly for most of them, for all of them generally, and so it shouldn't be a long assignment. Okay, the first thing is this. We're going to get data first, so you're going to click on this link right here. It opens up this file right here. There's 3 cities, A, B, and C. I'm going to go ahead and do A for you and show you how to do it, and then you can do the others. So first thing you're going to do is you're going to copy all the data here. Now, there's a lot of data. It doesn't end right here on row 25. This tells us it's row 25. It goes all the way down. So you're going to want to click on the first value, and then you're going to hold your shift key down, and you're going to hold your, and then take your arrow key, and you're going to keep going all the way to the bottom. You might be able to hit control shift, and it might go all the way down, so you may want to try that, but otherwise you can just hit the control button and go all the way to the bottom to make sure there's no more data. Okay, so that was the first one. And then what you're going to do, once you get all the data and you confirm that you've got it all highlighted, you're going to hit copy, which is control C, and when you do it, you see like a dashed line there. Okay, so now what you're ready to do is copy all this data, and as you notice, there's tons of it, right? So we can't just count it manually. That would take forever. So we're going to use technology. Specifically, Desmos is a great site for evaluating data. So now that we've got it, it's currently copied. The next thing we're going to do is we're going to go to Desmos. So what you're going to do is you're going to want to open up a new browser. Okay, so you're going to Control N, for me anyway, and you're going to type in desmos.com, DESMOS.com. Okay. And if you didn't find it, remember it's going to be Desmos right here, Desmos, but .com, okay? And then you hit Open Graphing Calculator, and now it's a blank screen, so we haven't put anything in there yet. The first thing we want to put in is our data. So we can go back. There should still be a dashed line. What that's telling you is that the data is currently being held or copied, so it's ready to be pasted into Desmos. Where'd Desmos go? Wait. Where did my Desmos go? There it is. Okay. So I'm going to just paste it in. But first, before I paste it in, I want to name my data set. I'm going to name it data A equals. And now it's ready to be pasted in. So I'm going to hit Control V to paste all the data in. See how that it's there? Not only that, but it tells me there's 216 different element lists. And by the way, this is, what kind of data is this? This would be temperature for 3 different cities. Okay. And we're looking at city A. All right, great. Now that once you've got it in there, what we're going to do is we're going to create a histogram. And so what you do is you click on the right underneath it. See how this says 1? This says 2. So you click right there, and you're going to type in lowercase letters, HISTOGRAM for histogram, parenthesis, A, comma, 5. And I'm going to explain that in a second. A is the data set. This has got to match that. Okay, it's got to be the same. It's got to be lowercase. And what's the 5? That's the bin width, remember. So instead of, seeing every single value, 40, 44, etc., you'll see bin widths of, say, from 40 to 44, or 40 to 45. So it's easier to evaluate the data. This is a good idea when you have hundreds of data elements like that. You don't want to just necessarily see every single one. Although we know with a dot plot we can. Okay, good. So we got a histogram. Well, what are we going to do with this information? Oh, and by the way, I should mention that. How do we know that the bin width is 5? Well, what we're going to do is, I told you in the instructions that the bin width is 5. So let me go back to the instructions over here. So I did tell you to put bin size 5. I'm going to have you do that for all of them, okay? For every data set. Okay, so then the next thing is we've got that there. Now, it's manually set to do bar heights of count and bin alignment of center. So make sure you leave it like that. If for some reason it's something different, go ahead and put it on count and center. Okay, good. So now we got our data. Now you might look at this and say, if you're looking at your Desmos graph, and you might say, well, geez, this doesn't look like all the data. Take a note at the axis. You've got from here to here, it's measuring how many, like 2, 4, 6. And more importantly, the temperature, these values for A are going to be listed here on this line right here. So these are very small numbers, but these are very big numbers, going all the way to 110. So what you're going to want to do is you're going to want to zoom out till you see the whole thing mostly. Okay, there we go. Then you can take a finger, one finger, and you can move it around like that, maybe to the center, and then hit zoom in a little bit. Take your finger, move it like that, so you feel like you have a pretty good thing. Otherwise, another thing you can do is you can take 2 fingers and you can stretch it out this way and that way. So, or you can go to the toolbar and you might say, hey, maximum value looks to be over here about 20 something. I'm going to make my maximum value say 30. Remember, this is the y-axis. So I'm going to go over here to the y-axis. And I'm not only that, I'm going to take my finger, move it down first of all. I want to see as much data as possible. Makes it easier to work with. And then I'm going to make it go up to 30. And check it out. All of a sudden we get all this great data right here. We can really see it. All right, so that's something you're going to want to do. Okay, well, what's the first question we get? Question number 1, how would you describe the data set regarding skewness in general? Okay, I'll tell you what, I'm not going to answer that. Well, I will. Okay, there's basically going to be 3 data sets. And this one here, if you look at it, in general, it's not perfect, but in general, it's what? It's pretty evenly split if you split it down the middle. So you should know what that is. The correct answer is going to be one where it's pretty evenly split, or bell-shaped, or symmetric. So I'll let you decide which one you think is correct based upon what you learned in the last 2 lessons. Number 2, which daily temperature appears in the bin range with the most frequency? Okay. Now this is not the specific temperature that appears most frequency. It's the bin range that appears most frequency. And what is the temperature that's in it? Okay, well, let's go back to it. Well, here you can pretty clearly see it's the center one. Now you may not see a number here, right? But you can zoom in. And again, so if you zoom in like that, all of a sudden you start seeing, hey, it's 55. As a matter of fact, if I want to see these values, I might go like this and say, hey, let me make the x-axis this way, have a step of 5, so that I see the steps a little bit better. Now I can zoom out again. Oops, maybe I have to zoom in a little bit. There we go. But there we go. So the one with the most is 55, okay? This is the tallest right here, so it's got 55. Okay, so what's the next one? Question number 3. A person likes temperatures from 70 to 75. How many days are included in the bins? In the bins including these temperatures. Again, 70 to 75, bins including those temperatures. Okay, let's go back to that. 70 to, wait, is it 70? Yes. Okay, now if you look at it, there is going to be 2 bins, right? 70 to 75. Well, how many are in 70? Well, keep in mind, we've got our y's over here, right? So one thing I can do is I can take my finger and I can move this over so that I see my 70 and 75. And there we go. I'll take my, there, and that's going to be easier because it's right next to this scale over here. Now, if I look at the scale, it's got 15 to 20. I could probably see that each block goes up by 1, it looks like. Or, I can go like this, and I can make my y have a step of 1. And check it out. Now I see it goes up by 1. I don't like all these little grid marks. I don't need decimals. So I'm going to take out the minor grid lines. And see how nice and easy it is to work with? Okay, well, 70 has how many? It has 6. I could go to the top. There's 16 in this bin. And then over here, there are 12. So 12 plus 16 is 28. Okay, so that's how many are in the bin. 28. Okay. Number 4 is asking what percent. Number 3 was how many days. But number 4 is what percent of the days are included in the bins, including those temperatures in the previous question. I should put a parenthesis there. Well, we know that it's 28, right? So we've got to take 28, but we need a total. What is our total going to be? Okay, so we know that the number of days over the of that bin, so 70 to 75 bins. We already know that that is equal to 28, but we've got to divide that by the total days that are in this thing. Well, how many? Well, remember when we did that, when we pasted the values in, what did we see? That it was 216 elements for all these data points. We don't have to count them. And so what was it again? 216. So I'm going to take that, divide by 216. Okay, so I got 0.1296, so I multiplied it up, and I'm going to round it to 13. So it would be 13% of the days are included. Okay, so that's how we can do that question. Okay, number 5. What percent of the days from our data set are less than the bin containing 90? Less than the bin containing 90. What percent of the days? Okay, well, we're going to go back to our bin. So how many are 90? Now, if I look at this and I say, geez, do I have to count all these that are less? It's to the left, isn't it? That's going to be a lot of counting from here plus this. But you know what? There's two options. I can either count all the days that way, or I can say, wait a minute, there's a lot less days going to the right, and they're a lot smaller. It's going to be much easier. So what do I need? I need less than 90, so I'm going to basically figure out how many are 90 and more. So I'm going to basically focus on those, 90 and more. And what do we get? We get, so 90 is 4, 95, 2, so 4, 6, 8, 2 here, 8. These are all 1, 9, 10, 11, 12. Okay, so there's 12. But that is going to be more than, or 90 or more. So that means, remember we had 216 total. So we have to go minus 12. That's going to be 204 that are 90 or under, less than 90. Okay, so then we divide that by the total number. Again, divided by a total number, 216 times 100, and I got 94. Okay, so that's how you can do that. Again, remember, there's two options. If you get a question, how much is percent is greater or less than 90, there's a whole bunch one way. Do it the opposite way, and then just subtract it from the total. Okay? Okay, so 6, 7, and 8, 9, and 10, actually the rest of them, you're going to benefit by knowing that box and whisker plots break down things into 25%. So what I'm going to do is I'm going to make another video, since this one's getting close to the end, and show you how to use a histogram, or not, I'm sorry, a box and whisker plot to do 6 through 12.